Okay, good morning, guys. Today we're going to learn area under curve. As I mentioned last week, today we won't do revision because we have to run the syllabus to prepare for your TE1, which will run on the digital version. Okay, so area under the curve. Previously you have learned. I mean, not previously. Like all this long you've been learning integration. Okay, so today we're going to learn something very new. Okay, the application part of integration. Okay, let me just get one pencil here. Okay. So, I'll just put in sideways. Hope you can see. Okay. So last time we learned dy over dx. Okay. So what is our purpose to do dy dx? Okay? If you recall, dy dx is to find gradient. That's the only purpose. Of course, in differentiation you have other applications such as rate of change. Okay. And then small approximation. Then you have the part the max or main. Then you have the part of stationary point. Okay, all this was covered under differentiation. Okay, and then when you learn when Miss Catherine taught you about integration, I'm very sure she already told you. Okay, integration is actually the reverse of differentiation. Okay, I'm just going to write dy dx. I repeat again, integration is actually the reverse of differentiation. Okay, but we all know dy dx application primarily is only served for gradient. Okay, that means when we do dy dx, you need to know what's the purpose we do dy dx. You already know by today, dy dx is just only to find gradient, and sometimes we use for some other application. But then now we're going to learn on what is actually integration in the application of it. Okay, allow me to explain myself first. I know some of you, when you go degree, you will notice that my teacher told me dy dx is only gradient but not anything else. Okay, but let me declare to you, okay, for this level your application of dy dx is very limited to gradient. Okay, of course, you know what is gradient, right? Gradient is to measure the steepness of a slope. Okay, sorry, bad spelling. That means whether the slope is steep or not steep. This is what we use gradient for. But actually gradient have more application than that. Okay, that you know. Okay, all this you'll count. You will, if you took engineering course or any course related to maths, you'll see that. Okay, so for now your syllabus, you know, dy dx to find gradient. Integration is the reverse of your gradient. That means from your gradient you're going to go to your equation. So what is so great about integration in here? Okay, so far you learned the method to integrate. Okay, there's few methods. One is by part. Then when you integrate ln, what happen? When you integrate exponential, what happen? When you integrate x cube, what happens? So and forth. So all those methods now we're going to use into an application. So now this application is I believe you've seen the topic already. One of the primary application, when you integrate, you can find area under the curve. Okay, bounded by axis. Okay, I repeat again, you can find the area under the curve bounded by the axis. Okay, axis can be two axes, y or also x. Okay, it depends totally. Okay, so I already told you that you integrate, you can get area under the curve. Okay, this is just a knowledge for you. You know dy dx got two type of dy dx, correct or not? One is the first one to find gradient. When we do second differential for what, guys? d2 dx. Okay, when we do second differential, what are we looking at actually? We are looking for the find the max or min. Still remember or not? Okay, so in integration, actually when you integrate one time you find the area. There's another one part in integration, but it's not covering your syllabus. I just want to tell you as a knowledge. When you integrate, not for the second time, there's another part in integration where you'll add a square to it. When you do integration also, you can find volume. That means integration is so powerful that you can use it to find area and volume, okay, bounded by the curve. I'm just telling you this knowledge because I don't want you later when you go to university you blame your teachers or what. Okay, so remember, you do integration, you can find area and also you can find volume. Volume you have another method, but still is integration. You have to square both sides of the equation, something like that. Okay, so this thing is not covered in your syllabus. You only cover area and this one. Okay, so remember area under the curve. So I'm going to explain to you my understanding of actually how when you integrate you get the area. I want to explain because why? So that in exam you can link easily. Okay, supposedly imagine I have this line here. Okay, so I say this line is intercept 2, and I say this equation is y equals to 3x plus 2. Take note, I'm just doing imagination now. So what I'm going to do, I'm going to give a point here. Okay, let's say I say this point, I need to get a very exact point here. So maybe I put 3 lah. So 3, 3, 9, 9 plus 2, 11. That means here should be 11. Okay, doesn't matter what we get. Okay, so now what I want to see is, let's say I want to find the area of this shape. You know what shape is this, right? This is a parallelogram. Huh? So assumption, I'm gonna do the calculation here. Okay, so what's the formula to find a parallelogram? 1 over 2 sum of parallel sides. So sum of parallel side means here I have 2, here I have about 11. Okay, so here is 2, here is 11. So 2 plus 11, and then my height is 3. Okay, so this is how we find the area of a parallelogram. So I'm going to calculate 1 over 2, 2 plus 11, and then times 3. Okay, so I'll get say about 19.5 here. Okay, so now I telling you I can use another method through integration also at the same time. So I'm just going to do integration. So I integrate 3x plus 2. So when I integrate 3x plus 2, I get 3x square over 2 plus 2x. Okay, done. Okay, so later I'll teach you the method how we integrate. Remember, after you integrate, I will put my limit here. I will explain to you later. Okay guys, don't get confused. So I just want to show you that through integration also you can get actually what you're searching for. Okay, so here 3 3 square is 9, so 9 times 3, 27 over 2 plus 6. Okay, you saw, you still get the same answer. You still get 19.5. So you do formula also can, you integrate also can. So what I'm going to try to tell you now, guys, okay, just now I already teach you that integration is actually reverse of dy dx. Integration reverse of dy dx, Miss Catherine taught you already. So when you integrate, okay, I write here, when you integrate, you're going one level higher. So when you go one level higher, that will actually give you the area of that what you are searching for. I repeat again, when you integrate, you go one level higher. That means initially your equation is like this. When you integrate, you go one level higher. So when you go one level higher, you are actually finding the area. I go through this long explanation because I want to prove to you that traditional calculation and manual calculation also will give you the area. Okay, that's what I want to explain to you. Okay, so there's a good detailed explanation of how actually this thing works. I'll try to go through the textbook for you. Sorry if this video wastes your time a lot. Okay, because I have to tell you the theory. Okay, so in your textbook they go through a theory whereby they say, imagine this curve. Okay, there's a curve here, and then they're bounded by the area. Okay, so this is where I want to tell you the story here. Okay, so usually in integration, if you want to find area, you only can find area of the curve with the axis. It decide which, depends which axis you're looking about. Like for here they're talking x-axis. That means I want to find all the area trapped with the x-axis, because some student might think let's say this is the curve. Okay, the curve is like this, and they think I'm finding all the area down here. Actually no, we only find the area from the curve all the way to the axis. That means the axis is your limit. Okay, so your area is from the curve to the axis, that's all. But you must define either you're looking x-axis or y-axis. For your syllabus they cover x-axis only, they don't cover y-axis. Okay, so now they said, imagine this is the area we're looking for. Okay, this is the area we're looking for up to this region. So they said, if I want to find this blue color area, so you see initially up to here it's x value. Okay, so I say maybe I want to top up a bit more. Okay, I want to top up a bit more, and I say this top up is delta x. So that means up to here is x, means up to here will be x plus delta x. Okay, I repeat again, if here is x, means this region here should be x plus delta x here. So what they're trying to tell you is, for you to get this region here, you must take x plus delta x minus x. I repeat again, let me just get the eraser. I know this explanation is hard, that's why I prefer the earlier one. Okay, so this whole region minus this pink color you should get here. Okay, because why? I'll try my best to explain. Like I said, from here, from this area, I expand a little bit more. So when I expand a little bit more, this one become x plus delta x, because I say I increase by an unknown value delta x. So this entire big thing minus this pink color, I should get this blue color region. I repeat again, this entire thing minus this pink color, I should get this blue color region. So that's what they do here. And then you see they already said. So for me to find the area, that small area is actually this bigger one minus the smaller one, I will get at. So at some point they they prove to you the calculation that delta A over delta X is Y, and then they got the calculus part and so and forth, then they prove you. Okay, you see this is too much of explanation, but that's the theory actually. But if you look this way, this is easier. Like I said, when you integrate, you are going one level higher. That means when you integrate, you go one level higher, means you are getting your area. This is a very I call it a layman explanation. Okay, you can go through this if you want, you don't want, also doesn't matter. It's just a theory, okay, to explain to you how integration work. Okay, so now that we're going to go through examples, I want to reiterate some important points here. Okay, so when we integrate, as I mentioned earlier, we only look up to the axis, we don't look anything beyond than that. For an example, okay, this video will be a theory video, later we'll do. So for an example, I have this curve here, okay, I have a curve here, and I want to look all the area up to this dotted line. Okay, so this will be the area looking right. Okay, this is the area I'm looking at. I don't look anything down near here, because why? I already declare I'm looking up to X. How you know whether you're looking up to X or not? The drawing is very bad. Let me just draw a proper one. So let's say I draw this curve. So I draw this curve here. Like this, I think this curve is better. Okay, so I want to look up to this area. Okay, so I'm looking up to this area. How do I know actually? You remember one part, when you integrate, you'll put, let's say the equation is x cubed plus x, and you'll write it dx. Remember or not? When you integrate, you put dx. That means this dx telling you I'm only looking all the way to my x-axis. That means my area bounded by x-axis. So my limit is up to x-axis. That means from the curve until x-axis is my boundary. I'm not looking anything beyond. So vice versa, let's say I want to look in terms of the y-axis. I'm telling you this is not covered in your syllabus, but just as a knowledge. So if let's say I'm looking for bounded by y-axis, that means you should see an equation here consisting of y, and I put my boundary dy here. You know why dy? Because I'm looking for the curve with y only. I repeat again, the curve with the y. Okay, so this is not important. We just need to know delta x dx. This means I'm saying you I'm looking all the way to the boundary of x. This means my curve until x only. I cannot further continue down there. Okay, so this is basically a theory, and then you integrate. So when you integrate time, okay, you need to take these limits and put inside. That means I want to know my area. Let's say I want to look my area from 2 to 3. Okay, so after I integrate, when I integrate this, I'll get x cubed over 3 plus x square over 2. Okay, so once I get here, I need to put value inside here. I'm looking from which area to which area, guys. Remember, I'm looking from area 3 to area 2. So you must write 3 and 2. You cannot write in another order. It always, because remember I taught you just now this example here. Okay, let me just go to a textbook. The textbook already cover for you actually. Textbook already say we're looking the larger one minus the small one. So if you take the small one first and the larger one, is the other way around already. You're going to sum that up. Okay, so you must take a larger one minus small one. That's the reason why we actually take 3 first and then minus with 2. Okay, we cannot put the other way around. Okay, that's how we do this integration. Okay, so this will serve as a theory video. Now I will go through the work example one by one with you. Okay.